Hello and welcome back, everybody. I hope you forgive the busy board, but I put up the sine and the cosine graphs for two reasons. One, we're going to use them as guides for later, but two, these are important graphs, the sine and cosine. Here's what we did last video, was we did a period of sine. So we graphed that much. Here's another period. So this is 2 periods of the sine. And here is 2 periods of the cosine as well. I could go labeling any one of these points. This is minus pi, minus 1, for example. But so I put that there, maybe you could zoom in or whatever. Those are important. Plus, we're going to use them as guides. And so this is section 6.2. Graphs of other trig functions, it's called. So we're doing the tangent, the cotangent, in order. We're doing the tangent, cosecant, secant, and cotangent in order. And we start out with the tangent. Please notice your calculators have the tangent function on, but they do not have the other three, because they're reciprocal. Somehow you would have to use the 1 over x button to get secant and cosecant and cotangent. But that's just a note. Calculator. Anyway, here's the tangent x. That's the equation we're going to graph, and we'll do one period. And whereas a period over here, when we did the sine, we went from 0 to 2 pi. 1 period for the tangent, we're going to go from negative pi over 2 to pi over 2. That's 1 period, and I'll show you how that works. And then we can take a picture and just move it, and we will do that. So here is the table of values. If I'm at pi over 2, negative pi over 2, the tangent of negative pi over 2 is infinite, because it's sine over cosine. And cosine at negative pi over 2 is 0. So because it's infinite, there must be an asymptote at negative pi over 2. And then at pi over 4, I have that point already right there. That negative pi over 4, negative 1, 0, 0 is on the tangent. This is pi over 4, 45 degrees. Tangent of 45 degrees is 1, so that's the point. Pi over 4, 1. And then here at pi over 2, oops, I'm using blue. There's got to be another asymptote, because that's infinite. And so the tangent, 1 period of the tangent curve is going to occur between these two asymptotes. And how that works, as x approaches pi over 2, the tangent of x gets bigger. Remember, it's a sine over the cosine. The sine's getting bigger towards 1, the cosine's getting smaller towards 0. So the tangent, the ratio of the two have to get bigger, so it's simply. The curve looks like this. Hits 0, and then it bends right. There's an inflection point, by the way. Bends down here and approaches that asymptote. And so that's 1 period of the tangent function, where pi over 2 and negative pi over 2 are asymptotes. So every single multiple of pi over 2 is going to be an asymptote. For example, pi over 2 plus pi. For example, 3 pi over 2. There's an asymptotic right there, because the sine over cosine of 3 pi over 2 is 0, so the tangent's infinite, and it's just this picture. It comes down here through the table, and through the table somehow. Here's, by the way, 3 pi over 2, that's 225 degrees right there. 5 pi over 4, and that's 1. And then it comes through, there's pi, that'd be 0, and of course approaches that asymptote. That picture and this picture are the same. Do it over here, you just keep going. Woo. That is the tangent. Right now we have 1 period, 2 periods, 3 periods of the tangent. A period is pi units long, but it goes from pi over 2, and negative pi over 2 to pi over 2, to 3 pi over 2, to 5 pi over 2. Odd number pi over 2. So that's a graph of the tangent, and I guess let me erase the top here and just some characteristics. The domain, I was just saying, is all the rails except x equals, let's see, pi over 2 plus or minus k pi. 1 pi, 2 pi, 3 pi. every other pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2. So it's the odd number pi over 2s. That's the domain except those numbers. And then the range is all reals. It just goes up and down forever. The range is all reals. It's periodic. And the period is pi. Right there, one period, you'll see it in a length of pi, an interval of pi. Here we went from negative pi over 2 to pi over 2, from pi over 2 to 3 pi over 2. That's a pi units long. And it has asymptotes. Whoops, where did I put that? I have to take this off. It has asymptotes, vertical asymptotes at domain. Domain equal at the domain critical points. It has vertical asymptotes at where is it? Oh, at all these. There's a vertical asymptote everywhere, and it either approaches negative infinity or approaches infinity, depending on. And you can just press buttons on the calculator to figure that out. Tangent. I think that's it. I'm going to erase. No, let's go over here. There's a caveat to this whole section. There's stretches, there's transformations, and we'll talk maybe a little about them, but we're not going to get heavily into them. Again, you have calculators. So we go back here. Here's the sine, and here's the cosine, and I put them up for two reasons. One, so that you would review what the heck they are, and two, because we want to do the cosecant. F of x equals the cosecant of x. And just please keep in mind that the cosecant is 1 over the sine. Oops, am I going to... No, I'll be fine. Is 1 over the sine, the reciprocals. So I want to reflect the reciprocals of this graph. Here's pi over 4, right? That's the point. Pi over 4... yeah, and 1. Pi, come on, sine. How about 30 degrees? It's right there. That's 30½ pi over 6 and 1/2. But now what I'm saying is this is going to be a reciprocal. So pi over 6 and 2 is going to be on the graph. Because it's just, we're taking the reciprocals of the range, of the y values. So, you know, that's a point on here. So what happens is when sine is 0, there's an asymptote. Everywhere sine is 0, there's an asymptote. You can't have 1 over 0, and remember they're reciprocals. And then what happens with this function, everywhere sine is 1 or negative 1 or 1, there's just a loop, you know, like so. It hits that point. The sine of negative pi over 2 is negative 1. The cosecant of negative pi over 2 is also negative 1. So it hits this point here. The sine of 90 degrees is 1. The cosecant of 90 degrees is also 1. There's a big U-looking shape there. Again, the guide is the pink, is the sine, and then there it just continues. One period of this, by the way, is 2 pi, because this and this together is a period. Or these two together is a period. So that's it's the same as the sine. So that's that one. The cosine is down here, and we want to do the secant. F of x equals secant of x. I'm sorry, I'm staying in front. And the same is true. Every time the cosine is 0, it's got to be an asymptote. Because remember, the secant is 1 over the cosine. 1 over 0 means asymptote. And we just do the same thing. Here at negative pi, the cosecant of negative pi equals the cosine of negative pi, which is negative 1. Here it goes like so. Here it comes down like that. Etc. Etc. And so that's what they look like, the white graphs, not the red. When you graph the cosecant or secant, you have to graph the sine and cosine first, because they're the guides, they're the asymptotic guides to the cosecant and secant. So I just want to talk a little bit about the characteristics of them, domains, range, that kind of stuff, and periodic, cosecant, domain is all the reals except where sine of x equals 0. So the cosecant is, you cannot put, cosine of x, sine of cosine. Sine of x equals 0. Right here, the sine of x is 0. The cosecant is undefined. You can't, that's not part of the domain. And then the range is all reals, except from 1 to -1. Do this, right? All right, let's put it this way. The range is negative infinity to -1. That's how I want to do it. Union 1 to infinity. That's the range. Domain, range, it's periodic. They both are. Period is 2 pi. The secant, everything here is the exact same, except the domain is where this cosine is equal to 0. Domain and range of those babies. And of course you can transform them. There's stretchers, there's pushers, there's all kinds of stuff. Phase shift, vertical shift. Again, there's stretchers. The period, by the way, it changes if you would imagine just pulling this. You're just stretching this thing out. That's what happens when you change the period. Vertical shift is moving up, moving down. Amplitude was a word that just goes. Amplitude here is 1 and -1. So that's all the trig functions. One more is the cotangent. Whoops, forgot about that. Cotangent of x. Let me think about that. Just put it on your calculator. Let's see, the tangent of 0 is 0, so there's got to be a asymptote here equals 1 over tangent, by the way. The tangent of 0 is 0. Tangent of pi over 2 is 1. So the cotangent is 1. Tangent of pi is 0. Looks like the cotangent goes like that. Yes, it does, as a matter of fact. It just continues like that. Nope, backwards. Sorry about that. Like that. Yeah, the cotangent actually goes like so. Just do it on the calculator. And again, there's stretchers, there's pushers, there's phases, and all kinds of stuff, which we would normally get to in a rigorous pre-calculus course. Hey, have a good one. I hope that works.